Hello and how are you doing? Today I'm going to start a totally new type of video. I haven't really thought about it until today. I would like to start on a new tutorial containing some programming language. It's going to be about C programming because I think that is very native to the idea of working with security, because it is a language you can use to access different kind of memory parts. It is a low-level programming language, but it's very close to assembler, and I think it's not a bad idea just to know a little bit about C when you are in security. But I'm not really gonna tie this to security. I'm not just mentioning that if you're already into security, this is not a bad idea to watch this tutorial. But I'm gonna basically just focus on the language itself, C, now how to compile. This is gonna be just a standard video. I'm gonna talk about, how to compile code. I'm gonna give some examples with on how a C program should look, and I'm gonna talk about variables and if statements and stuff, and I guess also loops. So let's see how much we can cover in one video before it becomes like a big mess. So let's first of all just talk about which kind of program I'm gonna use to compile our C code with. I'm gonna use the one called GCC, which is a program, and we can verify its version by typing gcc --version, and then we can see basically if there is an output, we have it installed, so that's really good. If you don't have it installed already, I suggest you go ahead and do something like sudo apt and get stall, maybe gcc, let's see, build essentials. Yeah, just looking at a guide here, you should install this build essential. There you go. And I guess I could just do it right now. And since I already have it, it's not really useful for me to do it, but I did it anyways. That is the command you can use. If you're on other Linux installations or distributions, there are of course other ways. If using brew, you could go ahead and type brew install GCC, which is another way, and not really sure how many other ways you can do it. Feel free to use any editor that the program on Windows you want to use. I'm gonna only use Linux because I think that is the most relevant tool I could think of that already got different compilers and stuff installed that I can use. Not really using my Windows 11 machine, which is this is a VM running on Windows 11, but not really going to use my Windows machine to do C code. I do write some C# code in Visual Studio on my Windows machine, but that is a totally different topic and it's more like private related. So I think we should just get started. We have the GCC installed, and I did the tac version, and we can see that I'm running a version of 10.2, and this is on a Debian machine. It is Linux Kali, so that is I think the version is being shipped with if you installed Linux Kali recently. So basically I'm going ahead and do our very first small program. I think it's a good idea to just go ahead and touch a file. Let's call it first.c. That is the program we're gonna do. So whenever you're gonna write some C code, you save it in C files because that is the name of the language, basically. So let's nano into that. So nano first, and I'm using nano. I know some hardcore guys saying you have to use VI, but I actually think VI is pretty irritating to use. It's very lightweight, but nano is, in my eyes, a lot easier to use. You don't need to deal with all these colons and escapes all the time, and that drives me nuts. I like nano a lot more if you're just gonna do fast stuff, and I guess this is a personal preference, but this is the way it is. I'm gonna do the very normal include here. Include the studio, as I used to call it, H file. First of all, let's just type in our first program because it's probably a lot easier to explain when it's already typed in. So print f and it's gonna be an hello world program today. So let's do hello world, and let's also return 0, and then that's about it. I'm gonna save this. So I think without further ado, let's go ahead and just, what is this studio thing and include? Now when you write C code, you need to include these .h files, and I'm not really. I think it's that is the file where that contains all the standard I/O, so standard input/output stuff functionality you're gonna use. So this is like you import in Java, or your includes another languages. This is where your references to your stuff is, like the printf is probably I'm pretty sure it's from st standard I/O. So you can also just go ahead and look it up on Google. Say stdio.h, what is it? And it says the header file, H stands for standard input output. It has the information related to standard input output functions. So that is basically it. And I guess we shouldn't really go any further right now, because that is, I guess the most information we basically need. Let's go ahead and compile this program. So I'm going to go out of this, and the way we compile it is by typing gcc, and you do the file, and then you do the -o for the output, or you can also do -- output like this. But I prefer just -o, and we're gonna call it first. And then we have our file first, and I don't think I gave it execution rights. It doesn't really matter. I could just execute it. Let's go ahead and look at it. Yeah, so it can be executed by anyone basically, and read by anyone really. So this is our first program. We just clear the screen and run it one more time. So now we create our first program where we can do an hello world. Now many of you already answered, can I do strings on this? Is this the way you do strings? Because whenever and I promise I wouldn't tie this to security, but I just really feel I want to say that yes, you can do strings on it. And if you do that, this is when you will look for stuff you're going to use, libraries and other binaries. And you can see that what I really do here is that I call printf and I do hello world. That's the only thing this program does. And all the other things you can see here is some standard stuff that's being input into the exe file, or the binary. And I'm really not really sure. I'm really caring about this. It is just there. If you want to learn about all this, it's not the part of when you learn C programming to do strings on a file and understand it. So I guess we should just go into the file and see what can we do. Let's go ahead and see. Yeah. So I think we should try and explain a little more about the code. Now, in normal C programming, and even if you're going to do like a standardized version of a C program called ANSI or ANSI, it kind of tells in the documentation that the main function needs to be an integer. I need to return a 0 as the final return value. That is basically what it tells you. But apart from that, this is a function where everything starts. If you use to Java, this is the same as the public static void main function. This is where your program starts. Basically, this is where it starts. So you have no classes, by the way, in standard C programming. This is a procedural programming language. You only have functions and stuff like that. Now you can do many different things with this printf function. I'm aware of you can do like some sort of value here. Let's say hello. And then you can insert, I think it's like %s. Let's try and do that just quickly. And this is where I need to recompile it and rerun it. And then you can see that I kind of replace the hello there with another hello, because let me go into the code. No. No. Nano, there we go. What? Yes. Okay. So you can see that I'm kind of replacing the %s, which is short for string, with the other value behind the comma, and that's gonna be my replacing value. But you can probably also just do normal concatenation operators just like this. I assume you can do that. I don't remember everything about C, so these videos I'm gonna do about C is also gonna be a learning curve for me. So I'm gonna learn a lot of stuff. Let's compile this. Now we do have some errors now, and it says invalid operand to binary, which is something we cannot do inside the printf function. So we cannot do plus sentences and all that stuff that we are used to doing when dealing with programming languages like concatenation. There's probably a way you can do it. I really don't know. It's so long time since I did any real C programming, but I guess this is for now okay, I guess. Let's have a look at some variables, I guess. Let's go ahead and do some standard variables. I think we should start up with the char variable this time. Char, let's call it var, and let's do 3 spaces with the word cat. I assume that would be a fine example. Now, what you could do here is, let's just, I think commenting out is 2 slashes, yes. So what we could do here is say, what about we say printf, and we do %c. Is that for char? We can just, go ahead and try stuff. So we're gonna take the first value of the array, or the char array, with 3 spaces, which is 3 spots, you can call it. So the first one is gonna be a C. Let's just try that and just basically compile it, and it's working. And I'm gonna output that. We could do. Let me just clear so you can see it a little more clear. So this is actually working. We do get the C, and it's very important. And this is something I do remember from my old C days, is that you use the percentage values correct. I'm pretty sure you cannot do %s because this is a char value, but let's try. Yeah, you could not do that. You're getting some sort of segmentation fault because it's not really it is not a string. It is a char value. So you really need to be very specific on your typing. So what I do think you could do is you could do a %s, and instead of doing 1, you do more than 1 value. You do all the characters. Then you're not in specific asking for a char, but you're asking for a string. So we're gonna compile this and go with, and now we're getting all the characters on the screen. So that is a really good way for you to output your characters to the screen whenever you have them from a standard char array. And it's very simple, but C programming is a highly insecure language to program in because it's so easy to make a mistake. But if you can do it correctly, it is really powerful. So let's see. Maybe it's about time that we create our first function. Let's go down here. I think in C programming we need to supply our functions in the top before the main. Let's try this. Let's create a one called temp here, like this. And inside temp, let's go ahead and do a printf, just like that. Alright, it's working. Then right here, let's go ahead and call temp, just like another language. Let's see if it works. Oh, sorry, I forgot to return something. So we need to return at least a value. There we go. Let's go ahead and, yeah, it does tell us that we have an implicit declaration of the function temp, which basically means we need to move it up. So this kind of, answered our. So let's do one here. Let's call temp again. So int temp. Yes, and then let's do a let's say that we can output any sort of array. Let's just call it, let's give it another name. It is C programming, so use for Java and C#. Let's call it name, because this is a print your name out. So this is print name, and then we're gonna do printf %s comma name, and we're gonna basically return 0. And now we're gonna go ahead here and call the function print name, go out of it, compile the program. We have another issue. Too few arguments. Did we not give it any? We did not. That is my fault. So let's go ahead and give it arguments, delete that line, and now we should actually print out this char variable here to screen. So let's go ahead and try that. No errors. Let me clear the screen and run the program, and it's working. So in C programming, it is very important that you do actually declare your functions in the top before the mention of the int main function. So that is one way of working with this. So let's go ahead and implement some more stuff in this function here. Let's do some if sentences. I think what we should do is to create a statement containing the size of, I think string length is a function in, yeah, and I think this is actually from the another include called string. We need to include that now. So this is very slowly taking space. So let's do string length and then do if statement saying if the size is equal to 3, let's print f out the size is equal to 3. And this is just a check, a verification. Let's go ahead and just compile this. It works, and we do see that the size is equal to 3 and the word cat is, and it works. It basically works. This is really nice, so yay. Now what we should do now is probably take a step back and reflect upon what have we learned so far. It's going really fast. I can feel that, because this is something I've done before, and it's very similar to Java and C#, but it is more strict and not really having any sort of code completion or anything, or any help or syntax highlighting in this. It's very basic, but I kind of like that. It's okay. So we have our int main function. We create a char array with the word cat, which is, I guess you can convert this to a restricted string with a fixed length of 3. I wouldn't advise you to call that to any teacher, but it's just to explain it. In C programming, you can create, and as I remember it, variable length strings, but you need to do it with pointers and some memory allocation and stuff, because there's no such thing in any computer as a variable length variable. It is a construct created with code that makes it look like it's variable. Even in Java, the string is an object that contains a fixed length, and if you use more than the length, it's actually being increased. But this is another talk. Let's see. I actually think this is really nice, interesting. So let's go ahead and just add some more to the if statements. What about the else if? Is it if like that? I think you need to give it highlights. So I think this is obeying the rule. You can say if size is not equal to Not equal to. Okay, it's gonna make that sign. Interesting. Yeah, we can print out printf. Sorry, the size is wrong. Let's go ahead and compile this and run it. And all right, so let's go ahead and create a new size. Let's say just CA, not cat, but CA. Let's go ahead and run this. And now we're getting the sizes wrong. So you can see that it works in the way we thought it would, even though that the array here is got 3 spaces. When you use the 2 of them, and C program does actually know that it's only 2 and not 3 we're having. Of course, there is also an else statement you could use, just like this. It is, in this particular case, not really used, so I'm not really gonna, it is, if you used to try it, you can do that. I think it's about time that we also try to give our program some inputs by having some sort of arguments, so let's do that. So let's go ahead and extend our program just a tiny bit more in the main method here. Let's go ahead and do the int argc and also the char pointer, which is a star argv array. Let's go ahead and do some output of those, and let's do percentage D. That's a number. If I remember this correctly, the argc is the count of the arguments, so we're gonna get a count here. And I want this separate on a new line, so I'm gonna do a \n right there. I'm gonna do another printf. Once more, a percentage s this time with a new line, and I'm gonna take the argv as my separate argument. So I'm gonna run this again. So I'm gonna compile the program, and this time when I run it, I'm gonna put in the word hello there, 2 words. Now I do get I do get some output that is correct. So let's go ahead and see, what did I do wrong? Oh yeah, I need to supply the star here because I'm pointing the value. Without the pointer, I'm not really pointing the value towards my output of the string. Let's go ahead and, whoops, compile it one more time. Let me just clear screen and hello there. So what I really do here is that I do output the 3 arguments. So it says 1, 2, 3. So the call to the binary is also one of them. And what I get out is first. Very interesting. So I guess that how to get all of it out? I guess we need to loop through it in some way, because it's not really gonna. So let's go ahead and comment this line out and do a for loop, I guess. Yes, and the for loop is gonna be having an integer variable starting from the index of 0, because this is also the same in C programming, that all positions start from 0. So as long as this is larger than argc, we're going to increment our I variable, and this is gonna printf out the %s, and I think the syntax, I'm actually looking at a tutorial right now, so let me just see. It can be done like this. So you're basically gonna say the pointer of whatever value is next. Let's try this now and say GCC and hello there. So it's basically gonna write, yeah, hello there. It is very clumpy, but you can see it right there, which is the exact value that we put in. So I guess this kinda concludes the first video about C programming. Not really sure how far I'm gonna go, But definitely I find this funny and nostalgic in a way. I I experienced C programming the very first time when I was like 18 years old, I think it was, and that's like 22 years ago. So it's a long time, and I find it funny. I do know. I do feel that I kind of can't see any practical use case at the moment where I use C programming, other than do simple sample whatever exploiting stuff, to exploit a system or some sort of vulnerability. But I guess this is also not a bad practical area to use it. It can help security and but creating a programming in C, I would say creating a driver in C is not a bad idea. It's really fast. But if you're gonna use C, it got a lot of memory issues that I would definitely not go into too much, because this is not for me. I'm not really a programmer. I'm all like working with security. So hope you liked the video, and see you again. Take care.